In our previous video, we were looking at importing the data into R and creating some basic data visualizations to understand how our longitudinal data unfold over time. In this video, we're going to be talking about the random effects that we might want to use in order to model this data appropriately, and then looking at building in some conditional fixed effects to really try to say, does variation over time change as a function of what group you're in? So we're going to adopt a strategy where we put in the random effects first and essentially control for the statistical dependencies within our data first, and then we'll consider adding in conditional models to decide which one is better. So hopefully you're following along with the information from the handout. And again, feel free to pause and rewind this video at any time in order to slow it down and help refresh yourself with some of the topics. So picking up where we left off, right, we're in line 84 of the code here, and we're going to build our first random effects model. So again, let's toggle back in our plot to this, where we're looking at individual data over time in each of those groups with different AIS grades. We are predicting people's Roche-scaled FIM scores, and what we want to do first is just include an intercept. We're going to include one overall intercept as a fixed effect, and we're going to include one random effect of the intercept. So we're estimating a unique intercept for each person. So we can run that model, and if we want to see the details of it, we can use the summary function to actually print the details of the model to the screen. So you can see those down here in the console window. Most importantly, kind of the easiest check on this is if we look at our fixed effects, there should only be one row there, because there isn't any group membership or any sort of slope for the effective time that we're modeling. We're just looking at the intercept. Now, R also allows us to extract some additional details of this model. So we get our summary, right, which tells us a lot of valuable information about what the random effects are and the fixed effects are. But if we wanted to say, for instance, look at each of the individual random effects, what do those look like? So we can print that to the screen in the console window. We'll scale this up a little bit. But you can see that that's a pretty long row. So getting the random effects from our model object, it gives it to us as a function of the subject ID. So we have the subject identifiers in the left-hand column, and then we have values for the intercept in the right-hand column. And the thing to keep in mind is these are random effects, so they're not the actual intercept values for each subject. They are the deviations for that subject away from the average. Okay, so in order to know what that average is, we could use the fixed effect function. So we'll get the fixed effects from our model object, and you see that returns only one bit of information. So that's a 44.90442. So that's our grand average intercept. That's our fixed effects across everyone in the model. That is the average value of the Roche-scaled FIM score that we would predict kind of across all people in this data set. Now, in order to understand what the intercept was for each individual person, we could take their random effect, which is a deviation away from the fixed effect, and just add the fixed effect to it. So people who are below, right, would have a score now that's less. They had a negative random effect. They now have a score that's less than 44. People who were above and had a positive random effect will have a score above and have a score greater than 44. We could add those two things together ourselves, but we can also get that from R using the coefficients function. So that's coef. So we'll get the coef for the random effects, and we can print that to the screen. And now again, you can see the first line is, or the first column, excuse me, is the subject identification numbers, and then we have the intercepts. Now these are the actual values in Roche-scaled FIM scores. So when I use the coefficients function, this is no longer the random effect. This is the actual value that is being fit for that person. Now, if you wanted to see the predictions of the model, or sort of what our fixed effects predict for each person at each time point, we could run the fitted function. So these are the fitted values, which is another way of saying the predictions from our model. So if we say fitted, you see it prints a lot more information to the screen. And the reason for this is that we have 720 individual data points. So it's no longer our individual subjects, right? It's not just our 40 subjects like we had when we printed the random effects to the screen. If we print the fitted values to the screen, it's printing 18 values for each of the 40 subjects. So if I wanted to get my model predictions, I could get them from the fitted function. And you can see that this sort of checks out because as an intercepts only model, because for subject 1, they have the same value for all 18 data points. Our intercepts-only model estimates a flat line for everybody, so that person has a flat line. Similarly, our second subject is going to have 18 cases of the same value because we're estimating a flat line for that person across time. And to help us understand this in a bit more detail, we can actually print this model to the screen. So I'm not going to go through the code that I actually have written in the script file, but you can run the code and get to the point where we plot our new model. And you can see here we've taken a random subset of the data to look at the first 10 subjects. And their individual scores over time are shown as gray dots connected by black lines. The fitted values from our intercepts-only model, or I should say our random intercepts model, are shown as red lines. And you can see each person has a flat line, because this is an intercepts-only model, but each person also has a different flat line because this is a random intercepts model. So hopefully this plot will clearly show what our model is estimating, and we are estimating a different intercept for each person. However, right, it's just an intercept. We have not estimated a slope yet. So to do that, the next model we will run is what we call the fixed slopes model. So the fixed slopes model, we now will have a fixed effect for time, which is referred to as month in the data set. So we're going to run that as month as a fixed effect. And note that in our random effects, we still just have a random effect of subject on the intercept. So this is a fixed slope random intercepts model. So again, we can run that. And as before, we can go through and actually see what the random effects are. Similar to the previous model, you can see that when we look at the random effects, we get one column of subject IDs and one column of intercept random effects. There's no random effect on the slope yet, so we only have a column of random effects for the intercepts. However, you will notice that the values here are actually different than the values in the previous model, because including that slope changes what the intercept actually means. When we run our fixed effects now, we use fixed f for our model object. We can see that we actually have fixed effects for the intercept and fixed effects for the slope. So our grand average, or sort of overall intercept, is 24.43, and our overall slope for the effective month is 2.15, and then some numbers to follow. So this has expanded our fixed effects because we added a fixed effect of month in the model. Now, when we look at the coefficients, right, this will give us the individual coefficients for each person. So we should have 40 rows, right, because we have one for each of our individual subjects. And then we have an intercept for each person, and then the month for each person. But you'll notice that all of the months are the same because, again, this is a random intercept, but a fixed slope model. So everyone gets exactly the same fixed slope. And we can see that if we plot the model object. Now, again, you can see the individual data points as gray dots connected by black lines. And you can see the estimates for each person as a red line. So those are the fitted values. And again, we have a random intercept. So each line has a different intercept, but it's fixed slope. So each line has the same slope. In the next model, we're actually going to have random slopes and random intercepts. So you can run through that code. The main thing to note is that here in the random effects line, we now have both a random effect for the intercept and the slope. We'll quickly go through to show the random effects. You can see that we have random effects for both the slope or both the intercept and the slope now. Our fixed effects stay the same, but our coefficients have expanded to now everyone has their own unique intercept and everyone has their own unique slope, and we can visualize that in the code provided to show the predictions for the random slopes, random intercepts model. And here I've tried to emphasize that by color coding each line separately, but each participant has their own unique intercept and their own unique slope. So I hope that helps you understand the difference in the random effect structures for the intercepts only model, or the random intercepts model, the random intercepts fixed slope model, and the random slopes model. In the next video, we're going to be talking about how to compare between these different models and assess model fit, and how to actually make conditional models in which we're adding more fixed effects in. So if we want to say, is the effective time different for males versus females? Or does the intercept depend on the severity of your initial injury? So tune in for that next video, and we'll be talking about model comparisons and evaluating fixed effects.